This question on board is one of the questions that comes from expansion in a solid. I've given the introduction part of it before. Please watch it. Now let's solve it. Now the question says a rod of length 500 millimeter is found to expand 1.3 millimeter when heated from 20 degrees Celsius to 100 degrees Celsius. Calculate the linear expansivity of the rod. Now, this question now, they say we should calculate the linear expansivity of the rod. The linear expansivity of the rod is the increase in length per original length per rise in temperature, right? So, the linear expansivity of a material is the increase, is the expansion in relation to the original length and the change in temperature. Take for instance, if a rod is in this length and you start heating it and the length changed to this, it has increased up to this extent, then the linear expansivity is the ability of this material to increase up from here to here. That is the original length. The original length initially is from here to here. There, but now when you start hitting it, it just expand to this length. So the linear expansivity is the expansion, is the increase, is this increase in relation to the temperature. If the temperature is from maybe when the original length is in, when it is 20 degrees Celsius, the original length is this. But when you start heating it up to 100 degrees Celsius, it has increased up to this. So now the linear expansivity will be the increase, this increase in relation to the change of this temperature from 20 to 100, comparing the original length, the increase in temperature change, and the original length. So you compare the original length and the change in temperature. What is the increase? Well, that is why we say the linear expansivity is the increase in length per original length per change in temperature. And the formula is this. Linear expansivity is equals to final length minus original length all over original length times change in temperature. So this symbol here, alpha, this alpha symbol is representing our linear expansivity of the rod. Then L2 is representing the final length of the rod. L1 is representing the original length, that is initial length before you start heating it. The same L1, which is original length, then this is change in temperature, that is temperature differences from initial temperature to the final temperature which you have heated it. And the question, and all of them is given on the board. So we are looking for this. We are looking for the linear expansivity of the rod. This is the one we are looking for. So from the question, they say that a rod of length 500 is found to expand up to 1.3. So they have given us the expansion already. They have given us the expansion, as in they have subtracted and given us how it has increased. You know, so the L2 minus L1 is already 1.3. They have subtracted and given us the increment, right? All over L1, which is 500. Then this change in length, this change in temperature means the final temperature, which is 100, minus initial temperature, which is 20. Continuing our solving, we now have linear expansivity equals to 1.3 all over 500 times 100 minus 20 is 80. So 500 times 80 is 40,000. 3.25 times 10 raised to power minus 5 per Kelvin. That is, our linear expansivity is equals to 3 times 3. Our linear expansivity equals to 3.25 times 10 raised to power minus 5 per Kelvin. The unit of linear expansivity is per Kelvin, which if we reduce it to decimals, we now have 0.0000325 per Kelvin. That is the final answer, okay? This is in standard form, this is in decimal form. This is how to calculate. I will solve many different kinds of questions from expansion in a solid. All you need to do is just to follow me on Facebook or subscribe on YouTube for you to get many things. Even apart from this, there are many things to come. Thank you for watching, and God bless.